Now that you've conducted your data collections, it's time to think about our analyses. But before we can analyze our data, we need to make sure that our data is input properly into a format that's prepared for those analyses. If you happen to use an online data collection format, having people do an online survey, then it's easy to export your data file into an Excel sheet format. But for most people, you will have collected data via paper and pencil surveys and now need to enter it into a format that allows for analyses. The easiest way to manage data, to clean it in preparation for analyses that will be conducted in SPSS, is to start by entering that data in Excel. There are a lot of functions that are much easier in Excel, and so we'll start using that program for our data entry. To enter your data, each row will represent a single participant's data. Each column should represent a single variable, or if you have a scale, each of the questions that makes up that scale will have its own column in our Excel sheet. So first you will label your columns using a shorthand notation that's easy to understand what that variable represents. So you'll start with your participant number, and then you may have a column if you have a between subjects factor indicating which condition your participants were in. For example, when we did experiment 1, we had those who were shallow processors and those who were deep processors represented by a condition variable. And so you should have a column for each of your between subjects independent variables. And for every question that you ask the participant, that question will have its own column to report as well. And you'll need to create a title that makes sense to understand what each question means. And so if it comes from a verified scale, you can just name it after that scale. So self-esteem question 1, self-esteem question 2. Or if you made up your own questions, you want to think about what's a shorthand notation to indicate what that question represents. For ease of use, I recommend having your column titles limited to 8 characters for ease of recognition. Right, so your first row will be these column headers, and each subsequent row will be for each individual participant. So to take a specific example, let's imagine that in running my study, I borrowed someone's 3-item happiness scale, and I'm coming up with a new title for each question. Right, so the 3 items on my scale are agreement with the following statements: I frown often, I laugh often, and I smile often. Right, so instead of putting that entire question text, which oftentimes is much longer than just 3 words, instead of having that as my column header, I'll just shorthand this into happy 1, happy 2, and happy 3. Right, so if I wanted to start setting this up into Excel, right, I have my first column be the participant number, the second column represents responses to the first question on my happiness scale, the second column is for the second question on my happiness scale, and the third column is for the third question on my happiness scale. And so once you have your column headers in the first row, you can enter the responses for each participant in the rows below. Now, if a variable is a scale and you want to just have one score for that scale, say you are averaging across those 3 happiness items, right, you're going to add an additional column for you to conduct that summary analysis, creating an average across your individual items. If you used pre-existing scales, you should make sure to go back to the original article to make sure you know the proper way to score each scale. Now, if you're just creating an average of a series of individual items that make up a scale, after you've entered the raw data for the response to each question, you're going to create an additional column for your summary statistic, whether it's an average or a sum of those individual scores. And this slide, I show you the notation for how to have Excel calculate an average for you. Right? So you just type into the cell, equal sign, open parentheses, type out average. Once you've done that, it allows you to highlight the cells that you want to include in your average. Once you've highlighted all your cells, close the parentheses and hit enter. In practice, it will look something like this. So after I've entered my participant numbers, I've entered the responses to my 3 happiness questions. I have a new column for my happiness average. Once I've highlighted this cell, E2, I can type in equals average, open parentheses. Then it allows me to just click and highlight B2 through D2. That represents that range of numbers here. Once I have those 3 highlighted, I can type in the close parentheses, hit enter, and it calculates the average for me. One other useful shortcut, once you've calculated that first average, you can highlight that cell again, E2. You'll notice that once it's selected, it has this solid border around it, and in the bottom right-hand corner of that cell, there's a little square. If you move your cursor over this little square in Excel, a crosshatch opens up. Let me show you this with actual data. Now, if you recall from experiment 1, we had separate recall and recognition tasks. But let's say we wanted to create an average memory score across those 2. I would create a title, average memory, type in equals average of, parentheses. I go highlight my 2 cells. Once the 2 cells are highlighted, type in the close parentheses, hit enter. And that gives me my average memory score for my first participant. Now let me highlight that cell again. I'll see that there is a square on the bottom right hand corner of the cell. Once I highlight it, this crosshatch comes up. Then I can click and drag down for as many cells as I want to fill in. And it will copy that formula for the appropriate row. So once you've calculated one average for one of your participants, you can easily copy that formula for your whole data set. One thing you want to think about is, does your scale have reverse coded items? Well, what do I mean by that? Well, sometimes scale creators have questions worded in the opposite direction from each other, so that high numbers on certain questions could mean high scores on your scale, whereas high responses on another question could be the opposite. Let me give you a specific example that might help illuminate this point. Let's look at our 3 items for our happiness scale. Happy 3 is I smile often. On a 1 to 7 scale, 7 would mean more happiness. Smiling more often, equating with more happiness. Happy 2, I laugh often, same thing. On a 1 to 7 scale, 7s mean more happiness. However, happy 1 is I frown often. On a 1 to 7 scale, 7s mean less happiness. So I need to reverse code the responses to happiness 1 so that I consistently have high numbers, high responses from my participants equating with a greater level of happiness on my scale. So I need to reverse code happy 1 before I take my average in order for this scale to make sense. To do this on a 7-point scale, I need to turn 7s into 1s and vice versa, 6 into 2s and vice versa, 5s into 3s and vice versa. One quick way to do that is to subtract the raw score from the highest value in your scale plus 1. So on a 7-point scale, the highest value is a 7. One higher than that highest point 7 is 8. So I can subtract each individual score from 8, and that will give me my reverse coding. So on a 5-point scale, you subtract the raw score from 6, and so on. So here, before I've created my happiness average score, I'll reverse code happy 1. I'll insert a new column for the score that needs to be reverse coded. I label it H1RC for reverse coding happiness 1. And by subtracting each cell from 8, I get the reverse coded item. So now high scores on H1RC correlate with high happiness, just like high scores on happiness 2 and happiness 3. I would then calculate my happiness average using only columns C, D, and E. I would ignore B from that happiness average calculation. Again, to calculate that reverse coding score, in the blank cell, just type in equals. For a 7-point scale, I'd use 8, so equals 8 minus, and then I highlight the cell. Hit enter, and it calculates that reverse coded score for me. I can do the same thing as before. Once I've done the first one, I can highlight this bottom right corner of that first cell, drag it up or drag it down to fill in the rest of the scores of all of my participants. So the main thing that you're going to need to do for your data cleaning likely is setting up your data file, indicating the participant numbers, having appropriate titles for your data columns, and then filling in the data from your paper into this Excel format. Once you've done that, you need to double check your scoring, make sure that you know how to reverse code any items, do those calculations, then calculate averages for your scales. Now, you don't need to create averages for the different groups of participants and your different conditions. SPSS is going to do all that for us. But what we do want to do is create summary statistics for any scales, full scales that we have. Once you've set up your data in this way, you'll be ready to conduct analyses next week. If you want to take a quick peek at your data, some things that you might be interested in doing. First, looking at visualizations. If you want to look at a scatter plot of two variables in conjunction, you can select the graphs option in SPSS, choose scatter.plot, select Simper scatter plot, click define. It'll show you this screen, which allows you to choose which variable you want on the y-axis, which you want on the x-axis before hitting OK, where SPSS will show you a visualization, a scatter plot visualization of your data. You may also be interested in running some simple correlations. That's also easy to do. You'll just select Analyze from the toolbar, highlight Correlate. Once you highlight Correlate, select Bivariate. This option box pops up, and then you can select all the variables that you wish to test, whether or not they're correlated. So you don't just have to choose 2 at a time. You can choose 3 variables, and it will show in a single table how the first is correlated with the second is correlated with the third, and the first is correlated with the third, all at one time. All you need to do is move over the variables that you want tested for correlations, hit OK, and it'll give you both the descriptive statistics, the mean and standard deviation of each variable, and show you whether or not these 2 variables are correlated. Show you the Pearson's correlation coefficient, the p-value, or whether or not that correlation is significant, and how many participants were in that analysis. If you are interested in taking a quick peek at your data before next week, all you have to do is, once you've set up your Excel file and saved that, you just select the import feature on SPSS, and you can import your Excel data directly. It will take that first row as its column headers, and you'll be ready to do these preliminary exploratory visualizations and correlational analyses on your own, just to get a sense of your data, or what might be going on there. The next week in lab, I'll work with each group to run the appropriate analyses for your data collection, whether that's between subjects, within subjects, or mixed model ANOVA. And so you don't have to worry about having those analyses done prior to coming into class, but you should get as far as you can in terms of inputting and cleaning your data prior to next Tuesday's class.